Now we're going to look at how sperm is produced. So, looking at the histology or the cells that are part of the seminiferous tubules, because remember, seminiferous tubules are going to be where sperm is produced. So, we have epithelial layers and then we have a fluid filled lumen that's going to have kind of, at least leading to the lumen, is going to have these types of cells. First are nurse cells. You might hear them as Sertoli cells as well, or type of sustentacular cells. These are going to be large cells that are going to be support and also help with sperm formation. We'll talk about those more later. Then we have spermatogenic cells. These are what are going to produce sperm. So spermatogenic cells, genic means produce. So these are sperm producing cells. We're going to have types of division. So we have stem cells, and then we have to go through meiosis 1, and then we have to go through meiosis 2 to eventually get to where we need to be. And then we have to go through spermiogenesis, which we'll talk about, to actually make sperm look the way they kind of should so that they can swim. We have myoid cells again. So myo means muscle. So these are going to be smooth muscle, kind of like, meaning that they're contractile. So these are contractile cells that are around the seminiferous tubule that can help squeeze the sperm and the fluid through the tubules so then it can lead to the ret testes and go into the epididymis. We also have interstitial endocrine cells. So endocrine meaning hormones. Talked about hormones before. These are also called the Leydig cells, so you might hear it that way. These are producing androgens. Mainly it's going to be testosterone production and some estrogen, because males do produce estrogen just like females produce some testosterone. So looking at spermatogenesis, again, how the steps of sperm production. Again, it happens in the seminiferous tubules. It takes about 5 weeks to finish. So to go from kind of the original cell to go to sperm. So there's first these three major steps. First is mitosis. And you're like, okay, well, we talked about meiosis. Why are we involving mitosis? It's because we have stem cells, and this is why we can continuously produce sperm. So spermatogonia are our stem cells. And spermatogonia are just going to divide and make copies of themselves. So they're going to form two spermatocytes, which are then going to go to actual sperm. So spermatogonia are going to go through mitosis, and you're going to form two spermatocytes. One is going to stay kind of spermatogonia so that we can have still our stem cell. And then the other one is going to go into spermatocyte primary and secondary. So we'll talk about that too. So primary and then secondary. So we want two copies so we can keep our stem cell supply. If we just wasted the spermatogonia and didn't do mitosis first, then we would have a limited supply of sperm, and that's not true. So sperm can be produced throughout life, or at least after puberty. So that's why mitosis comes in. Then meiosis. So we'll have meiosis 1, and then we'll have meiosis 2. So we'll go from primary, secondary, and then go to spermatids, which are going to be what's going to then go through spermiogenesis. So it's going to go through the cell. It has half the number of chromosomes. And then spermiogenesis is when it's going to get its swimming ability. So it's going to grow the tail. So spermatids become sperm. So again, first, mitosis of the spermatogonia. That's forming the spermatocytes. Spermatogenesis, so making a sperm, is going to begin at puberty. And again, spermatogonia, which are the stem cells that are going to be kind of on the bottom layer, are going to divide by mitosis, making copies of themselves, because again, we'll keep our supply of stem cells. After puberty, we have the type A daughter cells, which is going to stay a stem cell or stay a spermatogonia. And then we have a type B daughter cell that's going to develop into a primary spermatocyte. So it's going to go from spermatogonia to primary spermatocyte. So it's going to start moving up the line too. So it's going to move towards the lumen or the middle of the seminiferous tubule, because we're going to start at the bottom and we're going to move upwards. So again, this is looking at spermatogenesis. So first we have our spermatogonia right here. It has the full amount of chromosomes because we haven't gone through meiosis yet. So again, it's a stem cell. And you're going to produce through mitosis, so just dividing direct copies of itself, it's going to have the type A, which is going to stay here, say at the basal lamina at the bottom. And then it'll be available to do mitosis. So we're just making copies and keeping a copy for ourselves. So if we need to copy it again, we will. The type B daughter cell is going to lead into the primary spermatocyte. And it's going to start meiosis 1. Once meiosis 1 is completed, so it's finished, it's going to be a secondary spermatocyte. So meiosis 1, remember, that's when we're going to have half the amount of chromosomes. Then it has to complete meiosis by going through meiosis 2, and it's going to go from secondary spermatocytes to spermatids. Then those spermatids are going to go through spermiogenesis, which is what's showing here, where it's going to gain its ability to swim. We'll go over those processes later. So again, meiosis 1. Primary spermatocyte, so that type B daughter cell, is going to go through meiosis 1, and you're going to lead to 2 spermatocytes with half the number of chromosomes. That's what happens in meiosis 1. So we have the primary spermatocyte goes through meiosis 1, and we have 2 secondary spermatocytes. So meiosis 1. Then these guys are going to go through meiosis 2, and so then we're going to end up actually with 4 spermatids. So this is going to be meiosis 2. Spermatids are kind of, again, round cells. We haven't gained their ability to swim yet. And they're going to be closer to the actual tube. So these are going to be what are moved along, so then they can go through spermiogenesis. So spermatogenesis is making sperm. Spermiogenesis is making them able to swim. What happens with spermatids is we kind of compact the DNA into this tight little pellet little area, because again, we're going to make it a lot smaller. We'll make it just kind of a little head piece, a middle piece, and then we'll have a tail. So we want this kind of all compact into one little area because that's where it's going to go eventually when we go through spermiogenesis. So this is looking again. We have our kind of getting closer to the lumen. So this is the bottom down here, and then this is the lumen. So again, we're going to have nurse cells are going to be here. So cystinocytes or nurse cells are here. We have interstitial endocrine cells, so hormones here. Then we have kind of the basal compartment and kind of in this area, and then the upper part is going to be the lumen compartment. So we're going to have closer to the lumen up here and closer to the bottom down here. So again, here are the spermatogonia close to the bottom that are producing mitosis. So they're going to keep a copy of themselves, and then they produce the primary spermatocyte. Primary spermatocyte undergoes meiosis 1 to produce a secondary spermatocyte. Secondary spermatocytes then undergo meiosis 2, become spermatids. Then spermatids undergo spermiogenesis. So again, spermiogenesis is the ability to swim and become motile, so forming a tail. So spermatids to sperm. Spermatids already gone through all meiosis, so they have 23 chromosomes, but they can't swim. And that's one of the things that we need sperm to do. So spermiogenesis is going to be where it actually loses all the excess cytoplasm, forms that kind of head, and then it has a mid-piece, and then forms a tail that we actually see. So that's formation of the swimming sperm is spermiogenesis. Spermatogenesis is just getting to spermatids. I know there's a lot of sperm names. So if we look at a finished mature sperm, there's the head, the midpiece, and the tail. The head is going to be where the nucleus is, so it's going to be where the chromosomes are. And it also has the thing called an acrosome. That is going to have, so you have the head, which is going to have the nucleus with all the genetic material. It actually has enzymes that are going to help break down portions of the kind of protective layer of the egg and allow the sperm to enter the egg. So that's going to allow for fertilization. The mid piece is going to be where mitochondria are. So not only is semen producing or providing ATP, we need more. So what do the mitochondria do? The powerhouse of the cell. So there's going to be a lot of mitochondria here that are going to be able to produce ATP for energy, use the fructose in semen as well. And then last is the tail, which is the flagellum, which is a tail version to help with locomotion or movement. So that's where we can produce movement, where the sperm can actually swim. So just looking at spermiogenesis, what happens slowly is microtubules are actually helping from centrioles to produce the flagellum or the tail. Mitochondria are all going to kind of migrate to the midpiece. The nucleus is going to become kind of more compact and in kind of a triangular shape. The excess cytoplasm is going to be lost. You have that acrosome, which is the enzymes that help penetrate the egg. So you have kind of the final piece where it's the head with the nucleus with the acrosome. You have the mid piece, which is where the mitochondria are, and then you have flagellum or the tail, which is going to produce the movement of sperm. So when you look at nurse cells, which I mentioned, function of nurse cells are there kind of many functions. It is a supporting cell, and it does extend from the basolaminal to kind of the tubule layer. And they are surrounding all the developing cells of the spermatocyte and the spermatogonia. An important component that the nurse cells do is they have tight junctions. Remember, tight junctions don't allow anything to pass. So they can divide the tubule into its basal compartment with its spermatogonia, or the stem cells of sperm, and the luminal compartment, so higher up, closer to the lumen, where meiosis and spermatogenesis can occur. So where the sperm is actually being produced. Why are these tight junctions important? They produce what we call the blood-testes barrier. So you're actually dividing the blood and keeping it away from where sperm is being produced. So sperm can actually cause activation of the immune system if it's interacted with the blood where the immune cells are. Because sperm isn't formed until puberty, so your immune system is kind of all developed, and it hasn't recognized sperm as a self cell. It's seeing as a foreign cell. So sperm actually have to keep separated from the blood supply directly, because if it interacts with the blood, it's going to be considered a foreign cell and it's going to be attacked by the immune system. So it's going to be attacked by T cells and B cells. So this is why the nurse cells forming tight junctions is really important and a part of the blood-testes barrier, because without this, then sperm are going to be destroyed and not produced and not go through spermiogenesis. So you can see this is a nurse cell right here. And this is separating, so you have kind of nurse cells kind of all along that are forming tight junctions. So they're not allowing anything to pass. So we have the basal compartment, blood supplies down here. And we have the luminal, or the upper compartment, up here closer to the lumen, separated from blood supply, so that we can't have interaction. And this is where stem cells are. They've been there all along. So stem cells have been throughout life, but producing sperm and all kind of these cells up here haven't since puberty. So keeping those away from the blood supply is the blood-testes barrier. Nerve cells are also helping provide nutrients for division. They help move spermatocytes and spermatids closer to the lumen, or the end, kind of middle part of the seminiferous tubule. They also produce fluid that's going to have androgens like testosterone in there. They'll actually consume or phagocytize any cells that are seen as abnormal, and it'll also help with breaking down that excess cytoplasm. And a major thing that they do is help regulate spermatogenesis. So they are going to help determine whether spermatogenesis needs to occur, or if we have enough sperm and we don't need it right then. So it's going to either increase production or it's going to decrease production. So androgen binding protein is going to be kind of in the name. So it's binding, holding on to testosterone. Why do they need this? So nurse cells need to produce androgen binding protein because we need to keep testosterone levels at a high enough level that's going to help stimulate spermatogenesis. If you get low testosterone levels, then it's actually going to inhibit sperm production. so spermatogenesis. So, androgen binding protein helps stimulate spermatogenesis by keeping the testosterone levels appropriate. Nerve cells can also produce inhibin, which is a hormone, is kind of in the name, that it stops spermatogenesis. And it's going to stop follicular stimulating hormone, or FSH, released by the anterior pituitary. And we'll talk about FSH and LH at a later video.